Does AI really know what you're thinking, or is it just the world's greatest illusion? You've seen the magic. Now it's time to see the mechanics. This is how AI actually understands you. It's not magic. Right now, as you listen to my voice, something impossible is happening inside a black box of silicon. You think you're just typing a prompt, but behind the screen, a trillion connections are firing in a ghost-like imitation of the human brain. Most people think AI is just searching the internet. They're wrong. Today, we're peeling back the digital skin to reveal the terrifyingly beautiful logic of how AI actually hears you. By the end of this video, you'll realize that the way you talk to machines will never be the same again. What if I told you that AI doesn't actually understand a single word you say? It doesn't see letters, it sees a mathematical universe of patterns and probabilities. We use it every day for work and life, yet 99% of us are using it blind. Today, we're diving into the hidden architecture of the digital mind. I'm going to show you the exact methodology that turns your simple prompt into magic, and how mastering this logic is the only way to stay ahead in a world being rewritten by code. We've all been there. You type a question into an AI, and within seconds it writes a poem, debugs your code, or explains quantum physics like it's a recipe for pasta. It feels like magic. It feels like thinking. But here's the secret. AI doesn't think, it calculates, and the engine driving this machine is something called the transformer architecture. It's the T in ChatGPT, and it changed everything. Today, we're popping the hood and looking at the two engines that power this machine. Imagine you've read every book, every Reddit thread, and every Wikipedia page ever written. That's the training data. But to an AI, those aren't stories, they're statistics. We break all that text into tiny pieces called tokens. We build something called a vector database. Think of it as a giant multi-dimensional map. In this map, King is located near Queen, and Paris is located near France and Eiffel Tower. It doesn't know what a king is, but it knows the mathematical relationship between words. So when you type a prompt, say, explain gravity like I'm 5, the real work begins. The AI converts your words into those map coordinates. It uses a process called self-attention. The AI looks at every word in your prompt and compares it to every other word. It asks, what is relevant here? When it looks at the word gravity, it pays heavy attention to explain. Your prompt then passes through dozens of these neural network layers. Think of your prompt not as text, but as a raw signal entering a massive, dark labyrinth. This is the neural network. Your message doesn't just arrive at an answer, it has to survive dozens of hidden checkpoints. We can say the layers. The first gates, input layers, these are the sensory guards. They don't see words, they see raw mathematical patterns. They ask, is this a question? Is it a command? The deep interior, hidden layers. This is where the magic and the mystery happens. Imagine thousands of tiny digital filters working in a relay race. One layer identifies your subject, e.g., a golden retriever. The next layer detects your tone, e.g., sarcastic versus professional. Another layer searches for intent. Is the user looking for a fact or a joke? The final verdict, output layer. Only after your prompt has been stripped down, analyzed, and reconstructed through these layers does the AI finally understand you. It's a digital assembly line moving at the speed of light, turning chaos into total clarity. Now, the trap is set. The AI has your context, but it doesn't have an answer yet. It looks at the map and calculates a probability score for every single word in its vocabulary. That's usually 50,000 possibilities. It asks itself, what is the most statistically probable next word? Imagine a digital stadium with over 50,000 competing words, each one fighting to be chosen. In a fraction of a second, the AI runs a lightning-fast simulation. It's not thinking, it's predicting. It asks a single calculated question. Based on everything I know about the world, what is the most statistically perfect next word? The example, if your prompt is the sky is, the AI doesn't know the sky. It sees that blue has a 98% probability score, while green has 0.01%. The complexity, but if you ask for a sci-fi story about a sky, that map shifts instantly. Suddenly, neon or cracked becomes the winner. It does this for every single word. It's a mountain of math disguised as a conversation. Then it adds that word to the prompt and runs the entire process again, rinse and repeat until the sentence is complete. But here is where it gets truly obsessive. The AI doesn't just write a sentence, it constructs it, brick by single brick. Once it picks that first high probability word, it doesn't stop. It instantly feeds that word back into the beginning, updates its entire map of the universe, and starts the calculation all over again. The loop? It's a relentless cycle of predict, append, repeat. The scale? 50 times, 500 times, thousands of times per second. The example? If it's writing a code snippet for you, it doesn't just guess the code, it predicts the first bracket, reevaluates the logic, predicts the first variable, reevaluates again, and continues this digital rinse and repeat until every semicolon is perfectly in place. It is a masterpiece of math, built one tiny calculated heartbeat at a time. So, when the AI tells you a joke about falling apples, it isn't feeling the humor. It's successfully calculated the highest probability path. It's a mirror, reflecting the patterns of human language back at us using math and statistics. Thanks for watching. Want to know how we actually train these neural networks? Let me know in the comments, and I'll see you in the next video.